Have you ever watched an airplane soar through the sky and wondered how it moves with such grace and precision? The secret to this lies in the intricate design and engineering of its wings. The answer lies, in part, in a set of remarkable control surfaces known as ailerons. These small but mighty components are essential for the aircraft's maneuverability. Ailerons are hinged sections located on the trailing edge of an aircraft's wings, typically near the wingtips. They are crucial for the plane's ability to perform complex aerial maneuvers. These ingenious devices play a critical role in enabling an airplane to roll or bank left and right. This rolling motion is fundamental for changing direction during flight. Without ailerons, controlled flight would be impossible, and our skies would be a far less crowded place. The skies we see today filled with aircraft owe much to these small yet vital components. Ailerons work by disrupting the smooth flow of air over the wings, creating changes in air pressure that generate the forces needed for rolling motion. This disruption is key to the plane's agility. When one aileron is deflected upward, the other aileron simultaneously deflects downward. This synchronized movement is what makes the plane roll. This differential movement creates an imbalance in lift, causing the wing with the lowered aileron to rise and the wing with the raised aileron to drop. This imbalance is what allows the plane to tilt and turn. The result is a controlled roll that allows the aircraft to change direction and maintain stability during turns. This precise control is what makes modern aviation so reliable and efficient. Ailerons are essential for controlling an aircraft's movement along its longitudinal axis, commonly referred to as roll. Roll is one of the three primary axes of rotation that govern an aircraft's motion, the other two being pitch, nose up or down, and yaw, nose left or right. While the rudder controls yaw and the elevators control pitch, ailerons reign supreme over roll. To initiate a roll to the left, for example, the pilot uses the control stick or yoke to deflect the left aileron downward and the right aileron upward. This action increases lift on the left wing and decreases lift on the right wing, causing the aircraft to bank or tilt to the left. The degree of roll is controlled by the extent to which the ailerons are deflected. Small deflections result in gentle turns, while larger deflections produce steeper banks. The invention of the aileron is widely credited to the Wright brothers, Wilbur and Orville, who made history in 1903 with their groundbreaking first flight. The Wrights recognized the need for a reliable method of controlling an aircraft's roll in order to achieve stable and maneuverable flight. Their ingenious solution, which they incorporated into their pioneering aircraft, the Wright Flyer, involved a system of wing warping. Wing warping, a precursor to modern ailerons, involved twisting the wings of the aircraft to create differential lift. The Wrights achieved this by connecting a system of cables and pulleys to the wings, allowing the pilot to control the degree of warping. While rudimentary by today's standards, the Wrights' wing warping system proved effective and paved the way for the development of the more sophisticated ailerons we rely on today. Section 4. Boulton's Brilliance: Early Visions of Aileron Control. While the Wright brothers are rightfully recognized for their pioneering work on ailerons, it's important to acknowledge the earlier contributions of Matthew Piers Watt Boulton. In 1868, Boulton, a British inventor, patented a design for aileron-like control surfaces, predating the Wrights' work by several decades. Boulton's design, which he called horizontal rudders, involved hinged surfaces located near the wingtips that could be deflected to control the aircraft's roll. Despite his innovative concept, Boulton never had the opportunity to build a full-scale aircraft incorporating his aileron design. However, his visionary work laid the groundwork for future aviation pioneers, including the Wright brothers, who would eventually transform the dream of controlled flight into a reality. Section 5. From simple flaps to sophisticated surfaces, the evolution of aileron design. Since the Wright brothers' groundbreaking flights, aileron design has undergone a remarkable evolution, driven by advances in aerodynamics, materials, science, and flight control systems. Early ailerons were relatively simple, consisting of fabric-covered wooden frames hinged to the wings. As aircraft design progressed, ailerons evolved to incorporate metal structures, improved hinges, and more efficient aerodynamic profiles. Modern ailerons are marvels of engineering, often incorporating lightweight yet strong composite materials, sophisticated control systems, and even active elements that adjust their shape and deflection in real time to optimize flight performance. These advancements have led to ailerons that are more responsive, efficient, and reliable than ever before. Section 6. Taking flight, early aircraft, and the aileron advantage. Following the Wright brothers' success, numerous other aviation pioneers adopted and refined aileron technology, leading to a rapid proliferation of aircraft designs that incorporated these essential control surfaces. The aileron, a hinged flight control surface, usually forming part of the trailing edge of each wing, became a crucial component in the evolution of aviation. One notable example is the French Blériot 11, a monoplane that gained fame in 1909 when Louis Blériot piloted it across the English Channel. This historic flight marked a significant milestone in aviation history, showcasing the potential of aileron-equipped aircraft. The Blériot 11's use of ailerons for roll control contributed significantly to its stability and maneuverability, highlighting the advantages of this innovative technology. The success of the Blériot 11 inspired many other aviators to incorporate ailerons into their own designs. Another significant aircraft in the development of aileron technology was the Curtiss Model D, designed by American aviation pioneer Glenn Curtiss. Curtiss was a key figure in early aviation, and his contributions helped shape the future of aircraft design. The Model D, which first flew in 1911, featured ailerons mounted between the wings, a configuration known as interplane ailerons. This innovative design allowed for improved roll control and demonstrated the versatility of aileron placement. This design, while less common than wingtip ailerons, demonstrated the versatility of aileron placement and further advanced the understanding of roll control. The experimentation with different aileron configurations during this period laid the groundwork for modern aircraft stability and control systems. Section 7. Ailerons today. Essential components in modern aviation. Ailerons remain an indispensable component of aircraft design, found on everything from small single-engine planes to massive airliners and supersonic jets. These control surfaces are crucial for the roll control of an aircraft, allowing pilots to execute precise maneuvers. As aircraft have become faster, larger, and more complex, so too have the ailerons that control them. Modern advancements have led to the development of more efficient and responsive ailerons, enhancing the overall performance of the aircraft. Modern ailerons are often integrated with other flight control surfaces such as spoilers and flaperons to provide enhanced maneuverability, stability, and safety. This integration allows for smoother and more controlled flight experiences, especially in challenging conditions. The next time you watch an airplane gracefully navigate the skies, take a moment to appreciate the ingenuity and importance of ailerons. These components are vital for the seamless operation of modern aviation. These unsung heroes of aviation, working tirelessly behind the scenes, play a critical role in enabling safe, controlled, and efficient flight, connecting people and places around the world. Their contribution to aviation safety and efficiency cannot be overstated. From the Wright brothers' pioneering wing warping to the sophisticated ailerons found on today's most advanced aircraft, these remarkable control surfaces continue to shape the world of aviation and inspire us to reach for the skies. Their evolution is a testament to human ingenuity and the relentless pursuit of progress in aviation technology.